Hello, so I will be talking about the natural blind spot. So the natural blind spot is a place in the visual field where there are no light-detecting photoreceptor cells on the optic disc. So this creates an empty space or gap in our vision, but we don't actually notice this. Why? Because we have two eyes and the blind spot in one eye doesn't correspond to the same area as the blind spot in the other eye. So we don't have a blind spot in our visual field because one eye makes up for the other one. Even if we were just seeing with one eye, we won't notice it because we're filling in the blind spot. So as humans, our visual system makes an educated guess to fill in based on colors or patterns we're seeing. So people who suffer from migraines will actually experience or notice a blind spot in their vision because their blood vessels spasm and they temporarily lose a patch of visual cortex, which causes a gap or a blind spot. And this is called a scotoma. And we will be talking about that in a little bit. So the blind spot was discovered in the 17th century by Edme Marriott while he was performing a human eye dissection. He found the optic disc and discovered that an optic disc has no sensitivity to light. So why do we have a blind spot? Because the optic disc in the area is the area in the retina where the optic nerve leaves the eyeball. And like I said earlier, there's no photoreceptors where the optic disc is. So, filling in. We can test our own blind spot. There's examples in the book that you can try out if you haven't. So if you hold the image out in front of you, then like for these examples, if you close your left eye and look at the plus sign, and then were to slowly move the image closer, the dot will eventually fall on your blind spot and it'll go away. You kind of have to play with the distance to find your blind spot. So for the first example, instead of seeing nothing, we will fill in the image with the background color yellow. So this also works for a line. If you do the same thing with the line image, the dot will disappear, but we will fill in the line instead of there being a gap. Now, when the line is two different colors, we'll still fill in the gap. We won't just see an empty space. We'll actually see kind of like an ombre effect, and the two colors will kind of fade together. Also, with a pattern background, we will fill in the pattern. For this example of the blue dots with one red dot, instead of seeing an empty space where the red dot is, we will fill it in with another blue dot. I didn't put up a slide for it, but the odd thing is that if we try to put our blind spot on like a corner of a square, we can't actually fill in that corner. It will be an empty space there because it's too complicated to fill in a corner. Here's two more examples. The one that looks like spokes on a wheel, the lines will converge into the center. On the second one, these lines are not lined up straight. So what we will actually see is that the vertical lines will line up, but the horizontal ones will not. And then I found a research article, and they wanted to measure the time that it took for our filling in to fade when the target, which was where our blind spot is, was surrounded by dynamic textures and motions. And so they measured three different things. They measured intensity of illumination and directional contrast between the target and the background. And so both the target, which is what you were looking at, and the background, both of those were moving around. And then they measured changing target size and shape. And so they found that motion took less time to fade than when the texture on the blind spot was different from the background. And they also found that when the target got larger, it took the longest to fade.